This was one that was in the book. And we want to evaluate this integral from -2 to +2 of 4, the square root of 4 minus x squared dx. Now again, we should be starting to be more familiar with this, is if we take this x squared plus y squared equals 4, this is the same thing as in this form, x squared plus y squared equals r squared, which is the general form for the graph of a circle. All right? And then if we solve this for y to get an explicit form, if we subtract x squared from both sides and then take the square root, we've got y equals plus or minus the square root of 4 minus x squared. Now, we've talked about this before, the positive square root is the upper semicircle, and the negative square root would be the lower semicircle. And if you graph that, if you put this in your calculator, positive in one function and negative in the other, you get a whole circle. Okay? So this actually just graphs to be this. Okay, so this is actually a semicircle, and if we don't know, if we want to evaluate this, what we can actually do is just find the area of the semicircle, and that's going to be the value of the integral. That's the main idea. So what's the area of a circle? Well, area of a circle is equal to pi r squared. So that area of this whole circle would be pi times, and the radius is 2, so 2 squared is 4, or just 4 pi. But we want the area of the semicircle, so just that's half the area of the circle, equals 2 pi. And that's actually the value of that integral. So we could actually just state over here that the integral from -2 to 2 of the square root of 4 minus x squared dx just equals 2 pi. And you're done. So you've evaluated it using geometry or using areas. So this is what we call evaluating integrals by using areas. And as long as your geometry is good, no problem. Okay? Alrighty? Sorry, that's my cat. He wants out. Okay. All right, let's take a look at another example. This is another circle. You can see it over here. The integral from 0 to 3 of the square root of 9 minus x squared dx. And again, this is another circle. The radius is just going to be 3. But we want to just take the area in here. Okay. And that's just going to be from 0 to 3, so that's just going to be a quarter of the circle. So we do the same thing. The area of a circle is pi r squared. In this case, it's going to be pi, and the radius is going to be 3, so pi times 3 squared, or 9 pi. But we only want 1/4 of the circle, because we're going from 0 to 3, so that's just a quadrant of the circle, or 1/4. So we'll just take 1/4 the area of the circle, which is just 9 pi over 4. So that's the value, that's the value of our integral. Just 1/4 the area of that circle. So again, you could write down that the integral from 0 to 3 of the square root of 9 minus x squared dx is just equal to 9 pi divided by 4. Okay? That's not too hard. Again, if your geometry is okay, then we can just evaluate these geometrically. Okay? And let's try another one. Got one more here. And what we've got here is this integral from 2 to 5 of 3x plus 1. So this is just a line. So I graphed it. I used a different scale here so I could get everything in. So it's going 5, 10, 15, 20. Starts at 0, of course. And this is 1, 2, 3, 4, 5. So the scale is a little bit biased here. And if we think about graphing this line from 2 to 5, it's a line. The x-intercept or the y-intercept is 1, and the slope is 3. So it will look something like this. And we can check this at x equals 2. Y would be, well, 3 times 2 is 6 plus 1 is 7. So my height here would be 7. That would be the y value. And then when x is 5, this y value here would be 3 times 5 is 15 plus 1 is 16. So that would be 16. So the height here of this segment would be 16. And if we want to find the area under the curve from 2 to 5, that's just going to be the area of this geometric figure, which happens to be a trapezoid. So if I find the area of that trapezoid, I basically have the value of the integral. And the area of a trapezoid, is, remember, is 1/2 height times base 1 plus base 2. The base 1 and base 2, these are the parallel sides. So if I really kind of want to take a look at this, I kind of have to slide it around like this. And this is my trapezoid. This is the height, and these are my two bases. Okay, the height is 1, 2, 3, and the bases are 7 and 16. So those are the values I would put in for my area formula for a trapezoid. Okay, so we can get back here. So area equals 1/2 the height. Now the height is going to be 3. Okay, times the sum of the bases. And it doesn't matter what you call base 1 or base 2, so I can say base 1 is 16 and base 2 is 7, or vice versa. I'll just say 7 plus 16. And that's going to give you the area of this trapezoid, which is actually the same thing as the integral, the area under the curve, of this graph 3x plus 1 from 2 to 5. And we can evaluate that. Area equals, okay, area equals, and that's going to be 3/2. And 7 plus 16 is 23. And if I just multiply that out, that's going to just be 69 over 2, or 69/2. Okay, and that's your area. So we could actually just say that this integral is equal to 69 over 2. That's a definite integral because we do have lower and upper limits. And it's the same thing since it's always positive on this interval from 2 to 5. It's just going to be equal to the area under the curve. Okay? I hope that helps.